In this video, we're going to go over some examples using the double angle formulas. So the first example is actually example number 2, the first example for this video. Use the double angle formula for cosine to write cosine of 6x in terms of cosine 3x. Well, I hope that you guys notice that 6x is actually 2 times 3x. So we can substitute, this is our theta, 3x is our theta. And what are we gonna do? Well, we're gonna write, we know the formula, cosine 2 theta is cosine squared theta minus sine squared theta. So we're gonna take this and we're going to substitute our values. So the cosine of 6x is cosine squared 3x minus sine squared 3x. And that's it. And well, actually, that's not it yet, because the objective is to write cosine 6x in terms of cosine 3x only. We have 3x here, but we still have sine of 3x here. So we're going to substitute our sine with 1 minus cosine using our Pythagorean identities. And what are we going to get? Well, let's actually copy the rest of it. And don't forget that this negative actually affects this entire expression that follows, because that we're just substituting it for the sign. So the negative still stays there, so it needs to be distributed. And this is what we're gonna get. Cosine squared 3x minus 1 plus cosine squared 3x. So when we 3x. So when we combine these two expressions, we're going to get 2 cosine squared 3x minus 1. And that's going to be our last, that's going to be our answer. Let's take a look at our next example, example 3, and it says verify the following identity using double angle formula. And I'm gonna use our strategy for verifying identity. I'm gonna pick one side, work with it, and see if I can get it to be equal to the other side. And in this particular identity, I think our right side is actually more complicated than the left side. It's a square of a binomial. I'm going to use this formula that you should be familiar with. I just wrote it here to remind you of this formula. This is what I'm going to use to actually unwrap this right side of this expression. Okay, so what do we have? We have a squared, so sine theta squared plus 2ab, so plus 2 sine theta cosine theta plus b squared, which is cosine theta, so cosine square theta. All right, so that's our right side. Now notice that if I add sine squared and the cosine squared, that's our Pythagorean identity. So that's going to be equal to 1. Okay, so sine squared plus cosine squared is going to be 1. So I have 1 plus 2 sine theta cosine theta. Now, what's 2 sine squared cosine squared? I mean, sorry, 2 sine theta cosine theta. Well, that's a formula for the double angle formula. So this equals sine of 2 theta, okay, by the formula. So we have 1 plus sine of 2 theta, and that's exactly our left side right here. So that's how I deal with this example. And I want you guys to try this problem. Okay, so pause here and try and verify this identity. So pause and try it. If you can't, if it's too complicated, I'm going to give you a hint, but I do want you to try first. Okay. But if you can't, then I recommend that you start with the left side first of all and apply the difference of squares identity, which is a squared minus b squared equals a plus b multiplied by a minus b. So that's your hint. Now you should be able to solve it. So pause this video and go for it. And we're gonna continue our video and we're gonna tackle example 4, which says verify the identity, and it gives us tangent to theta equals 2 divided by cotangent theta minus tangent theta. So let's take a look. What I'm gonna do, I'm gonna use our identity for tangent to theta, this one, and I'm gonna use our tactics that we used before. I'm gonna set beta equal to alpha. So I'm gonna substitute wherever I see beta, I'm gonna substitute it with alpha because beta equals alpha. Okay. And so what do we have now? Here we're gonna have tangent to theta, right? What we have here. On this side, I'm gonna have tangent alpha and tangent alpha. So that gives me 2 tangents of alpha, right? And on the bottom, I have 1 minus, and then tangent alpha multiplied by tangent alpha. So that gives me tangent squared. Tangent of alpha squared. All right. So what am I gonna do? Look at this right side. This is what I'm headed. This is what I want it to be equal. So I see that I have 2 in the numerator, and here I have 2 tangent alpha. So I want to divide this numerator by tangent alpha. But if I do that, then I have to do the same thing with the denominator. So I'm going to multiply this by 1 over tangent alpha, the numerator. And I'm going to turn this 2 tangent alpha into a fraction by adding a denominator of 1. I'm going to do the same thing with the denominator of this fraction. So yeah, I'm gonna divide everything. No, okay. So let's do step by step. So not to confuse you guys. So eventually, when I multiply this fraction by that fraction, I'm going to have tangent alpha on the bottom, and then I'm going to separate it into 2 fractions. I'm going to separate it into 1 over tangent minus tangent squared over tangent. Okay. So, well, let's do that. Well, here I'm just going to cancel out tangent alpha. So that simplifies into 2. And here I'm going to have 1 over tangent alpha minus tangent squared over tangent. Well, you realize that tangent square alpha over tangent is going to be just tangent. Now, what is this? 1 over tangent theta. Well, that's our cofunction identity. So this is basically a cotangent. This is equals cotangent. And I keep on writing alpha, even though in our identity it's theta. But you got the idea, right? It's the same. It's the same. It doesn't matter what the name of the angle is, if it's gonna follow this pattern. So we got another identity for tangent of 2 theta that we can now use. So now please try to verify this identity. Cosine 2 theta multiplied by cosine theta equals cosine cube theta minus cosine theta multiplied by sine squared theta. Go ahead, pause the video and verify this identity. I'm going to see you in the next one.